Assalamualaikum and very good morning to our doctor. So today our group 18 will present about the case study that includes in industrial organic chemistry processes. So this is our team members. For the first question is the chemical mechanism for producing tires. So in the chemical mechanism, there are two ways to producing tire. For the first one is isoprene polymerization. Next one is vulcanation reaction. So basically, in isopolymerization is include isoprene, which is a monomer unit of natural rubber. So basically, it will involve the conversion of isoprene monomer into polymer known as cis-1,4 polyisoprene. So, to be general, the polymerization process is a formation of cis polymer when double bond in isoprene molecule undergoes a 1,4 addition reaction. So it will change into cis configuration, whereby it is a kinked or coiled conformation characterization. The cis 1,4 polyisoprene polymer, which is contributing to its unique properties such as elasticity, resilience, and flexibility. Next is the vulcanation reaction, whereby a sulfur cross-linking mechanism occurs, which is important to generate the cross-linking between the natural rubber polymer change. The rubber polymer change will react with sulfur atom in order to form sulfur bridge. This formation of sulfur bridge is important since it will act as the cross-linking agent, linking the adjacent polymer change together through covalent sulfur-sulfur bond, which will convert the linear polymer change into a 3D network structure. So it is important to improve the mechanical properties of the rubber material and also improve the tensile strength, tear resistance, and elasticity of the rubber. To get deeper into the isopolymerization mechanism, there are 5 steps that include in this mechanism. So the first one is initiation, propagation, toxicity, isomer formation, and also microstructure. To begin with initiation, the Lewis acid like aluminum chloride or boron trifluoride will react with isoprene to form carbon cation. This carbon cation will act as the active center for polymerization. Next is the propagation, whereby when the carbon cation is formed, it will undergo the propagation reaction, whereby this formation of polyisoprene occur when isoprene monomer is added to the growing polymer change. Next is the tacticity, whereby the arrangement of R and S configuration along the polymer change will give rise to the ester isomers, leading to different tacticity in resulting polymer. Next is the isomer formation, whereby the stereospecific polymerization of isoprene allow for the synthesis of highly stereoregular polymers such as like cis-1,4 polymer isoprene, trans-1,4 isoprene, 3,4 isostatic, 3,4 symbiotic polymers, which is contain different structure and also properties. Last one is microstructure, whereby the microstructure of polymer isomer will depends on how the monomer units are linked, such as like head-to-head, tail-to-tail arrangement that can affect the properties of the polymer. On the other side, for vulcanation reaction mechanism also involved in 5 steps, which is the first one is formation of sulfur radical, reaction with double bond, cross-linking, network formation, and also curing. In formation of sulfur radical, it will have the addition of sulfur into the rubber. The heat vulcanation accelerator is used to break down the sulfur into sulfur radical, which is highly reactive. Next is the reaction with double bond, whereby the polymer change formed with the sulfur radical to react with double bond. This will lead to the development of carbon-sulfur bond, which is linked in different polymer change together. Next is cross-linking, whereby forming more sulfur radical react with double bond from neighboring polymer change. It is used to enhance the strength, elasticity, and durability of the material. Next is the network formation, whereby 3D network of interconnected polymer change with sulfur bridge throughout the material. And lastly, curing, which is allow the formation of well-defined structure. This is used to enhance the mechanical properties of the vulcanation rubber. We move on to the preparation of natural rubber for producing. In producing tires, there are six steps that occur. For the first one is harvesting and coagulation, whereby in harvesting step, the harvest from rubber trees by using tapping, whereby the latex is collected in cups. For coagulation, formation of rubber coagulum occurs once the latex is treated with a coagulating agent in order to isolate the rubber particles from the liquid latex. Next is mining, whereby the rubber coagulum will undergo mining machine to form thin sheet of natural rubber, whereby it's used to eliminate and excess water and impurities from the rubber. Next is compounding, whereby the natural rubber is compounded when mixed with vulcanic agent, which is sulfur, acylator, and antioxidant and filler. This is important to control the final properties of the rubber compound, such as like strength, flexibility, heat, and also wear resistance. The vulcanization a process whereby the rubber compound is heated in the presence of sulfur or other vulcanizing agent. It's a process whereby cross-linking the polymer change in the rubber, imparting strength, elasticity, durability to the material. Next step is shaping and curing, whereby shaping the vulcanized rubber into different components of such as like thread to sidewall and mix will undergo the process such as construction, molding, and also calendering. Curing is used to secure proper shaping and properties components heated in mold under pressure. Quality control is used to verify the quality of the natural rubber, meets the specification requirement for the type performance, durability, and safety through physical and also mechanical properties of the rubber compound. Next, for the main chemical present in natural rubber is main chemical that present in natural rubber is cis-1,4-polyisoprene, also known as polymer of isoprene with a cis configuration. Generally, the collection of 320 to 3,500 isoprene molecule contained in this cis configuration, which contains some of minor impurities of organic compounds such as like protein, fatty acid, resin, and also inorganic materials such as salt. For instruments and tools that use to identify the presence of chemical compound, basically generally used is Fourier transform infrared spectroscopy, also known as FTIR, nuclear magnetic resonance spectroscopy (NMR), and also gas chromatography or mass spectrometry. So, FTIR and also NMR spectroscopy are used to detect the chemical structure and composition of natural rubber. For example, like FTIR and 13C NMR used in analyzing the benzene extract of figure 2 and rubber 3. For GCMS, is employed to identify and quantify the volatile organic compound occurring in natural rubber. Example, to study the smelly compound that are released during the storage or thermal degradation of the block rubber. So for the chemical structure of polyisoprene is as stated in the slide, whereby N is represented as the repeating unit or monomer in the polymer change. Generally, the chemical structure is knitted together through covalent bonds to form a long chain of isoprene. So, there are 4 isomers that contained in the polyisoprene, which is cis-1,4-polyisoprene, trans-1,4-polyisoprene, 3,4-polyisoprene, and also 1,2-polyisoprene. For the properties of polyisoprene, there are 4 that are highly tensile strength, good resilience, excellent elasticity, and also resistant to tears and abrasion. So for high tensile strength, it will able to show high tensile strength, where it's able to resist stretching forces without breaking due to its intermolecular forces between the polymer chains. It is important to apply to provide durability and also resistance to deform. Next is good resilience, where able to change back to its originality after being stretched or compressed. This is important characteristic as it's required to absorb energy and also recover their shape quickly. Next is excellent elasticity, where it's able to return to its original shape due to the fact that it is flexible of carbon-carbon bond in the polymer backbone and also use it for flexibility and also stretchability. Next is resistant to tears and also abrasion, whereby it can resist tears and also abrasion, and also suitable for use to wear and also tears. For the application of polyisoprene, there are 5, which is the first one is tire manufacturing, sport equipment, medical and surgical industry, engineering application, and also used in various industry and laboratory. So, as we know, polyisoprene is majorly used in tires due to the fact that it has highest tensile strength, resilience, and also elasticity, which leads to an ideal material for tire production. In sport equipment, polyisoprene has excellent tensile strength, elasticity, so it's used to produce sport and leisure products. For example, like soccer, slingshot, resistant band. For medical and surgical industry, it's used to replace natural rubber latex in medical devices such as like surgical covers, catheters, medical stopper due to its hyperallergenic properties. For engineering application, it's used to handle high level of stress in surface, for example, like rubber roller, shock absorber, and damping. And lastly, used in various industrial and laboratory, whereby it can resist inorganic chemical, physical degradation, tears abrasion, and also flex fatigue.
5 industrial production methods of acetone involve curing process from alkene nitrile, oxidation of isopropyl alcohol, ozonolysis of alkenes, and fermentation process. Curing process involve reacting benzene with propylene in the presence of phosphoric acid to form cumene. Then cumene is oxidized using air at elevated temperature to form cumene and peroxide. It is then cleaved into phenol and acetone. Production of acetone from alkene nitrile involves the reaction of acetone nitrile react with methyl magnesium bromide, and it is followed by hydrolysis. Then at the end of the hydrolysis, we can get acetone as a final product. Oxidation of isopropyl alcohol involves the reaction between isopropyl alcohol undergoes oxidation by reacting with potassium dichromate, resulting in the formation of acetone. Ozonolysis of alkene involves the reaction of 2-methyl-2-butane reacts with ozone in the presence of methanol to form ozonide. Then ozonide undergoes ozonolysis reaction to produce acetone and acetaldehyde. Fermentation process involves the use of bacteria, which is Clostridium acetobutyllicum, to convert sugars such as corn syrup into acetone, butanol, and ethanol. So next, the chemical mechanism of cumin hydroperoxide formation involves three steps, which are protonation and water loss, addition of water and proton transfer, and lastly, elevation. So the first step, protonation and water loss, cumin will react with oxygen to form cumin hydroperoxide. Then the OH oxygen of the peroxide is protonated, creating a good Levy group. Then this is followed by rearrangement where the phenyl group shifts from a carbon to oxygen with a simultaneous loss of water. Second step, addition of water and proton transfers. So the resulting carbocation is attacked by a nucleophilic water to form a protonated heavy acetal, which is bound to the same carbon atom. Then a proton transfers occurs with the oxygen near the ring taking the extra hydrogens. The last step, which is elimination reactions, is where an interactions occur which form the C-O in the product acetone, eliminating phenol as the other product. Chemical reaction of cumin process involves three steps. Step 1, alkylation of benzene is where benzene is reacted with propylene in the presence of phosphoric acid to form cumin. Then step 2, oxidation to the hydroperoxide is where cumin is oxidized using air at elevated temperatures to form cumin hydroperoxide. Then the last step, which is the cleavage to products, is where cumin hydroperoxide is cleaved into phenol and acetone as a final product.
So for ethylene hydration is basically a chemical process whereby converting ethylene C2H4 into ethanol C2H5OH by using water in the presence of catalyst. So the chemical equation includes C2H4 in addition of water H2O to produce H2H5OH. This process is whereby the double bond in ethylene is broken down and the hydrogen atom from the water is added to one carbon atom, while a hydrolyzed group, which is OH, is added to another carbon atom to form ethanol. So generally, the catalyst that being used is silica aluminide, zeolite, and also sulfate zirconia. So this reaction will occur in fixed bed reactor with a phosphoric V acid coated onto a solid silicon dioxide as catalyst. This is important to produce ethanol, which is widely used as solvent, fuel additive, and also producing a variety chemical end product. So actually, there are two ways in order to chemically producing of ethanol. So the first way is through fermentation, whereby there are 7 steps that include in this fermentation process. The first one is feedstock selection, whereby the biomass feedstock like sugar beets, sugarcane, corn, wheat, barley, and agriculture industry are used as the main source for ethanol. Next is pre-treatment whereby physical, chemical, and physicochemical and biological treatment occur, but it used to allow the biomass to be more convenient for the next step. So the next step is saccharification, whereby complex carbohydrate in the biomass change into a simple sugar like glucose. This is important to increase the ethanol yield for fermentation. The next step is fermentation, whereby fermented by yeast to convert into ethanol and carbon dioxide. So yeast will act as changing the sugar into ethanol for anaerobic fermentation. For distillation is used to isolate ethanol from water by distilling ethanol water mixture. So it will allow the purification of ethanol and also enhance its concentration. For dehydration is a method whereby the molecule receive or distillation. So it is used to further purify the ethanol from the distillation in order to improve their concentration. Lastly is the denaturation, which is used to provide the ethanol that is unsuitable for human consumption. So it is a important step to produce fuel and other application. So in production of ethanol through ethylene hydration, involved in three process, which is the first one is catalytic hydration, whereby it's a process for converting ethylene into ethanol by reacting it with water in the presence of catalyst. So usually this is the first step that involved in catalytic hydration of ethylene. Next is the optimization of operating condition, whereby it played important roles in optimizing the operating condition. For example, important parameters that include in this operating condition includes pressure, temperature, steam to ethylene ratio. So for the operation condition, pressure usually in 70 to 80 atm, temperature is 250 to 300 Celsius, steam to ethylene ratio is 0.6. This is usually used so it's able to increase the regulation of the ethylene hydration process and also control the yield and the quality of the production for ethanol. Lastly is the reactor design, whereby isothermal plug flow reactors are usually employed in producing ethanol production. This is used to support the reaction exothermic nature, which is crucial for the optimal conversion for ethylene to ethanol. Temperature control also important in reactor design, whereby it's used to avert the alteration of temperature, which can affect the reaction kinetic and also overall conversion regulation. This is to make sure that it is suitable range for ethanol production. Next, for application of urea are usually used in fertilizer, cosmetic and personal care, animal feed, and also chemical manufacturing. So for fertilizer, it's usually applied as the nitrogenous fertilizer for crops, usually employed in making urea ammonia nitrate to form liquid fertilizer. It is play important roles by generating essential nitrogen nutrient for the plants to develop and also for growth. In terms of cosmetic and also personal care, it's applied in skincare products, soap and also washing powder to moisturize and also scrub the skin. This is used to able to maintain the moisture in the skin, which leads it as a common ingredient in lotion, cream and also ointment. In terms of chemical manufacturing, act as the precursor in synthesis of various chemical and also compound, generally used in producing urea formaldehyde resin, which is important in manufacturing in creating molded items, eliminate coating and also adhesive. It is also used to enhance the performance of diesel engines and also reduce the gas emission by adding urea to diesel fuel. Lastly, for animal feed, act as the source of supplement protein and nitrogen for the livestock in order to increase the protein content. For application of butylene, also play important roles in polymer production, butanol production, fuel additive, and also alkali production. In polymer production, it is served as important monomers in the production of various polymer. For example, like butene 1-ene and also I2-butylene, which is used in manufacturing polyethylene and also polypropylene. For butanol production, able to produce butanol when undergoes chemical reaction that involve hydration of butylene. These butanol are important for solvent, fuel additive, and also in manufacturing in creating coating, pen, and also plastic. Fuel additive is used in producing methyl third butyl ether, or known as MTBE, and third butyl alcohol, or known as TBA. This MTBE and also TBA act as additives that are employed in gasoline in order to minimize the emission and also improve the octane rating. Lastly, for alkalis production, isobutyl plays important roles in alkaline process, whereby it will react with isobutene to generate high octane gasoline known as alkaline. It's used to enhance the quality of gasoline.
So there are 5 steps to prepare cooking oil using palm oil, which are fruit sterilization, fruit threshing, fruit digestion, fruit pressing, and lastly, oil filtration. The first step, fruit sterilization. So the palm fruit bunch are put in the palm fruit cage, then the fruit cage are put into the sterilization tank with a raw pan for sterilization. So the purpose for sterilization are to increase the humidity of the fruit and to destroy the activity of the fat decomposing enzyme. Second step, fruit threshing. So after sterilization, the palm fruit bunch will be transported to the drum-type thresher to separate the fruits from the bunch stalk. It can be separated by rotating them, and the animation above show how it works. The third step, fruit digestion, is where the palm fruit will be transported into digesting tank to break down the fruit structure and release the oil. The crude palm oil that was produced during the digestion process will be transported to the crude palm oil temporary storage tank. The fourth step, fruit pressing, is where the digested palm fruit are pressed to extract the crude palm oil for use in margarine and cooking oil, while nuts and kernel are pressed to produce palm kernel oil for use in cosmetic or pharmaceutical products. The last step, which is oil filtration, is to make the final palm oil cleaner and less impure from fibers and free fatty acids. Fats and oils are lipids known as triglyceride, which consists of 3 fatty acid molecules attached to one glycerol molecule. Fats play roles in cell structure and the absorption of fat-soluble vitamin, which consists of saturated fats that contains only a single bond in their fatty acid chains. For example, butter, meat, and cream. While oils are viscous liquids that occur in fruits or seeds of plants, which compose of unsaturated fats that contain no double bond in their fatty acid chains. For example, coconut oil, avocado, and nuts. While oils are liquids that occur in fruits or seeds of plants, which compose of unsaturated fats that contains no double bond in their fatty acid chain. For example, coconut oils, olive oils, avocado, and nuts. The differences between vegetable oils and animal fats based on taste is vegetable oil has mild and neutral flavor, while animal fats has rich and pronounced flavor. For stability, vegetable oils is more prone to oxidation at high heat due to high content in unsaturated fats. However, palm oil and coconut oils are high in saturated fats, making them more unstable for cooking. The stability for animal fats is it is more heat stable and less prone to oxidation due to high content in saturated fats, so it can withstand high cooking temperatures without breaking down. Vegetable oils contain vitamin E and omega-3 as nutrient, while animal fats contain cholesterol and fat-soluble vitamin in it. So the figure above shows the flowcharts of oils and fats processes. So first, palm oil seeds or fruits will undergo extraction to extract the oil by pressing and rendering. After that, the extracted oil undergoes deguming to remove phospholipid. Then the acidic components in the oil are neutralized to improve its quality by alkaline function. The oil then undergoes bleaching to remove odor and color pigments by activated carbon. After that, it will undergo deodorization, where odor and color are removed through steam at high pressure. Then, it undergoes fractionation to separate different triglycerides to produce fats. Last but not least, the oil is then packaged for distribution and consumption.